Find the equation of the conic with vertex 0, 2, center 0, 0, and eccentricity, denoted by E, equal to 4/3. Solution. In this problem, we have an eccentricity of 4/3, and that's bigger than 1. So whenever this happens, you're going to have a hyperbola. So we have a hyperbola, and that's because the eccentricity is bigger than 1. So usually in these problems where you have to find the equation, it's a good idea to draw a little picture as it helps clarify your thinking. So there's the x-axis and there's the y-axis. And we're told the center of this hyperbola is 0, 0. And we're told one of the vertices, right? We call it a vertex because it's singular. So 0, 2, that's going to be up here. That means the other vertex is down here. And the vertices lie on the actual hyperbola. So this means that this hyperbola opens up and down. Okay, and we know that because the vertices actually lie on the graph of the hyperbola. This will let us write down the general form for the equation. So whenever the hyperbola opens up and down, the y comes first. So it's y squared over a squared minus x squared over b squared equals 1. If it had opened left and right, it would be x squared over a squared minus y squared over b squared equals 1. But it didn't. It opens up and down, and so the y comes first. This distance here is a, always by definition. And we know that this distance is 2. So we've pretty much used everything except the eccentricity. Well, we did use it, I guess, to determine that it's a hyperbola. Now we're going to go back and use it one more time. So the eccentricity is equal to 4/3. And the formula for this is actually c over a. And we know one of these variables. We know that a is equal to 2. So 4/3 is equal to c over 2. Plugging in a equals 2. Then we can cross multiply. So 2 times 4 is 8. And then 3 times c is 3c. Solving for c by dividing by 3, we get c equals 8/3. Okay, so we have c, we have a, we've used everything we have in the problem, we just have to find b. So now we're going to use a formula that relates a, b, and c. So in a hyperbola, c squared is equal to a squared, and then to figure out the sign here, just look here, it's always the opposite. There's a minus sign here, so you put a plus sign here. So if this was an ellipse, you'd have a plus sign here, and you would have a minus sign here. So just take the opposite. It's a super cheesy trick that always works. C is 8/3. So when we square that, oh wow, we're going to get 64 over 9, right? 8 squared is 64, 3 squared is 9. A is 2, so when we square that, we get 4, and then plus b squared. All we have to do is carefully solve for b squared. Subtracting 4, we have 64 over 9 minus 4 equals b squared. To subtract these numbers, we need a common denominator. So an easy way to do this is to multiply the 4 by 9 over 9. So we end up with 64 over 9 minus 36 over 9. Okay, and that's equal to b squared. Okay, equal to b squared. And I'm cheating. I'm using my calculator to subtract because I don't want to mess up. I suppose you could do it in your head. This is 28 over 9, and that's equal to b squared, right? 64 minus 36 is 28. And now we have b squared. It's 28 over 9. We have a. A is 2. So a squared is 4. And so now we're going to take these numbers and plug them into our equation, and then we're done. So we have y squared divided by a squared, so over 4, minus x squared divided by b squared, so 28 over 9, and that's equal to 1. Let's go ahead and rewrite that second term just to eliminate the complex fraction. So we have y squared over 4. When we divide by 28 over 9, it's the same thing as multiplying by the reciprocal, so 9 over 28. So this is 9x squared divided by 28. And this is equal to 1. And that's it. I hope that made sense.